Okay, for this session, let's talk about sets. A set is a collection of objects. The objects in a set are called elements of the set. So for example, the set of barangays in Talisay City. That is an example of a set. And when I say elements of the set, an example of a barangay in Talisay City is example Puok. So Puok there is an element of the set. A well-defined set is a set in which we know for sure if an element belongs to that set. Let's have examples. The set of all movies in which John Cazale appears is well defined. Name of the movies and what named the movies and what do they have in common? There are only 5. The set of all movie serials made by Republic Pictures is well defined. The set of best TV shows of all time is not well defined. Why? Because it is a matter of opinion. The same thing, like for example, the set of best Cebuano dishes. Because my favorite dish might be not your favorite dish. So there is no criteria for it to be the best dish. But if I'm going to say a set of all mayors in the province of Cebu, that is well defined because I can enumerate the mayors there. And whatever my answer is, that is the same answer as the other Cebuanos. Okay? Notation. When talking about a set, we usually denote the set with a capital letter. The roster notation is the method of describing a set by listing each element of the set. Like for example, let C be the set of all movies in which John Cazale appears. The roster notation would be: set C contains The Godfather, The Conversation, The Godfather 2, Dog Day Afternoon, The Deer Hunter. All 5 of these movies were nominated for Best Picture by the Motion Picture Academy. Another example. Set of teachers in your school. So you can enumerate your teachers there. Like for example, I'm going to be enumerating Sir Tigle. And your other teachers, you enumerate them as well. So meaning, that is an example of a roster notation. Like in mathematics, for example, 2, 4, 6, 8, 10. I'll be writing that in a set. That is an example of roster notation. Example, let set A be the set of odd numbers greater than 0 and less than 10. So the roster notation is simply set A contains 1, 3, 5, 7, and 9. More on notation. Sometimes we can't list all the elements of a set. For instance, Z, the set of integer numbers, or the set of integers. We can't write out all the integers. There are infinitely many integers. So we adopt a conventional way of using the 3 dots. The dots, which we call ellipses, mean continue on this pattern forever and ever. It continues infinitely. Like for example, you have there the set of integers. Going to the left would be the negative integers. Going to the right would be the positive integers. Like example, the set of whole numbers. We have 0, 1, 2, 3, so on and so forth. Now let's have the set builder notation. This is another way on how to describe a set. You already know how to do roster rule or the roster notation. Let's have the set builder notation. When it is not convenient to list all the elements of a set, we use a notation that employs the rules in which an element is a member of the set. This is called a set builder notation. Like for example, set V is a set of people such that they are citizens registered to vote in Maricopa County. Another example, set A, wherein it's a set wherein X such that X is greater than 5. So you have noticed that this one is read as such that. And this is the set that has all real numbers greater than 5. The symbol, you have there a vertical line, is read as such that. Okay, let's have the types of sets. First, we have what we call the finite set. It contains only a countable number of elements. Like for example, municipalities of Negros Occidental. Another example, the barangays of Talisay City. You can count the barangays of Talisay City. You can also count the municipalities of Negros Occidental. That's why they are considered as finite set. Infinite set. The counting of elements has no end. Example, set of positive integers. Another example, 0, 1, 2, 3, 4, which continues infinitely. An empty set or a null set. So take note, infinite set, the elements cannot be counted because it continues infinitely. It's impossible for you to count that. In finite set, the elements are countable. An empty set or a null set. Set that contains no elements. We will be using the two symbols. It's either of the two symbols that you're going to use when you write an empty set. Like for example, set D is a set containing the Prime Minister in the Philippines. Now my question is this. Why is this empty? Now, do we have a Prime Minister in the Philippines? We don't have. That's why that is empty. Another one. The Lady Mayor of Talisay City. Now, right now, the Talisay City Mayor is Samsam, right? Now, Samsam is not a lady, of course. So therefore, if I'm gonna have a set like the lady mayor in Talisay City, that is an empty set or null set. Next, a unit set. Set with one element. Like for example, the mayor of Cebu City, the president of the Philippines, the mayor of Talisay City. For sure, you only have one mayor in Talisay City. We only have one president in the Philippines. Same thing, we only have one mayor in Cebu City. That's why it is considered a unit set. Universal set. The set containing all objects or elements, and of which all other sets are subsets. Like for example, you have sets A contains 1, 2, 3, 4, 5. Set B contains 2, 4, 6, 8. Therefore, the universal set is simply the set of all numbers containing both A and B. So therefore, the universal set is simply 1, 2, 3, 4, 5, 6, and 8. Let's continue with this types of sets still. Equal set. If the sets have exactly the same elements, let's have an example. Set F contains M, A, N, G, and O. Set G contains A, which is also found in F, N, which is also found in F, G, which is also found in F, O, M, both are found in F, meaning all the letters in A are also found in F. That's why the two sets are equal sets. And that is denoted as A equals B. When I say equivalent sets, if the sets have the same number of elements, Now, how many elements do we have in set H? We have 1, 2, 3, 4, and 5. In this set, set I, we have 1, 2, 3, 4, 5. Set H has 5 elements. Set I has 5 elements. Therefore, they are equivalent sets because they have the same number of elements. And take note, that is denoted by H is equivalent to I. Joint sets. Sets that have common elements. Look at the two sets. What is common? You have noticed that 2 is common. That's why the two sets are joint, since 2 is common between both set J and set K. Disjoint set. It's the opposite of joint sets. Sets that have no common elements. Like, for example, these 3 letters here and these 3 letters here. No common letters. Therefore, the two sets are considered disjoint sets. And lastly, subset. Set A is a subset of B denoted by if every element of A belongs to B. Like for example, let's have this figure. This is a set containing, this is set B. So set A is inside set B because all the elements in A are found or belongs to B. Let's have the 4 set operations. Let's start with the union. The union of sets A and B, take note for the symbol of union. This is the symbol for union. Is the set of elements that are members of either A or B or both. To dig deeper, let us help us understand. Let us use the Venn diagram. So we have here a Venn diagram. Now this is not my question. Which region should be shaded? Is it region 1? Is it region 2? or is it region 3? Well, of course, it would be the 3 regions, because union is simply list all the elements found in A or B or both. So you will be writing all the elements found in A or in B or both. Like for example, find the union of the 2 sets. The first number, the first smallest number, we have 1. Check. Next, we have 2. Check. We have 3. We have 4. We have 5. We have 6. We have 7. You'll be writing 8 ones and the number 9. Now, I am simply writing it in order so that no number will be missed out. There you go. Do not repeat the same elements, and we will list all the elements of both A and B. Another example. What is the union of X and Y? We have the letter A, of course, the letter B to be written once, the letter C to be written once again, the letter D, the letter E to be written once, the letter F, and the letter G. And that is simply the union of X and Y. Let's go to intersection. The intersection of sets A and B, written as, so take note of the symbol for intersection, is the set of the elements common to both A and B. So, common elements nila. And take note, if the intersection is empty, wala may common. So, you call it a disjoint set. But if they have something in common, you call it joint sets. Let's have an example now. To dig deeper, let's use a Venn diagram. Now, this is now my question. Which region should be shaded? Well, of course, that would be region number 3. Because region number 3 contains common elements of A and B. Let's have an example. Now, what is the intersection of A and B? Of course, the number 8 is common in both A and B. Therefore, the intersection of the 2 sets is simply 8. There you go. We'll list the elements which are both found in A and B. What about this? What is the intersection of X and Y? What is common? A is not found in Y, so I will not be writing A. B is found in Y, so you write B. C is found in Y, you write C. D isn't found. Letter E is found in both sets. And F isn't found. G isn't found either. So therefore, the intersection of X and Y are simply B, C, and E because they are the elements common to both X and Y. Difference. The difference of sets A and B is the set of the elements that are in A but not in B. So our focus here is simply the first set. The first set, we will subtract the elements found in B because we will not be including elements in B for our answer. So let's have an example. Before having the examples, let's have the Venn diagram first. So what is A minus B? It's simply we are gonna be focusing on A. Yeah, since region 3 has elements found in B, I will not be including the elements in region number 3. It's only in region number 1. Let's have an example to further understand the concept of difference. Okay, so take note, we will be focusing on set A. Now let's start. Is 2 found in set B? No. So I will be writing the 2. What about the number 4? I will be writing the number 4 as well. Sir, how come you have not written 6, 8, and 10? Because 6 is found in B. I will not be writing that. 8 is found in B. In B. I will not be writing that. And 10 is also found in B. I will not be writing that. Now, sir, how come you have not written 7 and 9? Now, are these two elements found in A? So our answer are simply the elements found in A. And we will thus subtract the elements there that are found in B. It's that simple. We will remove 6, 8, and 10 from A to get 2 and 4. Let's have an example. Let's reverse now. What is B minus A? So my focus now is on B. Let's write down the number 7. Why? Because the number 6 should not be included. B will deduct that. The number 7 should be written there. The number 8, it's not included because the number 8 is found in A. You subtract that. You write the number 9. And the number 10 is being subtracted in the set. There you go. The answer is simply 7 and 9. Remove 6, 8, and 10. Okay? Now, the complement of a set. The complement of set A, written as A prime, is defined as the set of elements that are contained in U, the universal set, but not contained in set A. So you are going to be writing all the elements except the elements found in A. That's the complement of set A. Now look at this one. The yellow part and the blue part is what you call the complement of A, because this is simply set A. So I will not be writing the elements found in A. I will be writing all the elements outside of A. Okay? So meaning, if I'm going to have this question, what is the complement of A? Look at this one. 6. I will crush out 6. 7. 8. I'm gonna have 7 here, by the way. This is 1, 2, 4, 6. That ay 7 din ha, and you also have 9 there. So I will be crushing out the numbers 6, 7, 8, 9, and 10. So what is left there is 1, 2, and 4. So take note, we will not include the elements of A. Kay the complement of A man atong gisolve. So ang nahibilin na jud ana sa universal set, si 1, si 2, ug si 4. Because 6, 7, 8, 9, and 10 are found in A. Again, you will be writing the elements not found in A. Remove 6. Okay, there you go. Now this time, let's talk about relations and functions. A relation is a set of ordered pairs. So you know what an ordered pair is already. This is an example of a relation because this is a set of ordered pairs. Now the domain. The domain is a set of all x values in the relation. So take note, in an ordered pair, the first number is what you call the x value. The second number is what you call the y value. Another term for the x value is the x coordinate or the abscissa. The y value, you call that the y coordinate, and that is the ordinate. And another term for an ordered pair is simply coordinates or coordinates. So what is our domain? The domain is simply 2, -1, 4, 9, and 0. So we can arrange that from smallest to largest, by the way. What is the range? The range is a set of y values, the second numbers. So you have there 3, 5, -2, 9, and negative 6. And you can arrange that from smallest to largest as well. Now, a relation assigns the x's with the y's. So if I'm going to assign 1 to 6, 2 to 2, 3 to 4, 4 to 8, 5 to 10, another way of writing the relation is simply 1, 6, because 1 and 6 are being paired a while ago. 2, 2, 3, 4. These are the pairs we have made a while ago. So this is simply another way of writing or expressing or describing a relation. Okay, let's have a function now. By the way, we have 3 kinds of relation. It's a one-to-one, many-to-one, and one-to-many. And you will learn all those 3 things as we go along with our slides. Now let's go to function. A function f from set A to set B is a rule of correspondence that assigns each element x in the set A exactly one element y in the set B. Let's have this set. The set A is the domain. And you have there, set B is the range. So take note, we need to consider the first condition. Must use all the x's. Second one, the value or the x value can only be assigned to one y. Exactly one y. Let's have this example. I'm going to assign 1 to 4. 4 to 8, 2 to 2, 5 to 6, 3 to 10. Let's examine the first condition. Must use. By the way, this is an example of a one-to-one relation. You have noticed that we have assigned one value of the domain to only one value in the range. One value in the domain to one value in the range. So if this is a relationship, this is what you call stick to one. Okay? So you have one-to-one relation. Now let's examine if this is a function or not a function. All x's are assigned. Yes, look at this. All the x's, they have assigned values in the range. Check. Second condition. Do we have the value of x can only be assigned to one y? 1 assigned to one y, 1 4 only. 2 assigned to 2 only. 3 assigned to 10 only. 4 assigned to only one y. 5 assigned to only one y. So therefore, no x has more than one y assigned. Therefore, that's a check. So this is a function. So take note, a one-to-one relation is a function. Let's have another example. Let's decide whether this is a function. And let's determine another kind of relation. I'm going to assign 1 to 4, 4 to 4, 2 to 4, 5 to 4, 4 to 4. Now, what kind of relation is this? We have so many values of the domain assigned to only one value in the range. And this is what you call a many-to-one relation. So take note, if you have 2 or more values of x's in the domain assigned to only one y or one value in the range, then that is a many-to-one relation. Now, let's determine whether this is a function. Must use all the x's. Correct. We have used all the x's 1 to 5. The x value can only be assigned to one y. Look at number 1. Sir, gi-assign na sa 1 y. Okay, number 4. 2 assigned to only to number 4. 3 assigned to only number 1. Y assigned to only one y. 5 assigned only to one y. Therefore, it meets the condition. That's a check. Therefore, a many-to-one relation is also a function. So take note, you already know that a one-to-one relation and a many-to-one relation, they are both functions. Let's have the third kind of relation. I'm going to be assigning 1 to 2, 2 to 10, 3 to 8, 4 to 6, and I'm going to assign 2 to 4 again. So this time, I have assigned number 2 to 2 values, to number 4, and to number 10. And this is what you call one-to-many relation. You have one value in the domain assigned to 2 values in the range. That's a one-to-many relation. Now, this is now the question. Is the relation shown above a function? No. Why? Because you have assigned 2, which is the domain, to 2 values in the range, and that violates the rule there. No, it is not a function. Therefore, a one-to-many relation is not a function. Okay? Now, why not? 2 was assigned to both 4 and 10. There you go. So, di yun asa pwede. Now, let's verify. Is this a function or not a function? Assign that. Assign that. Assign. Assign. Here's the question. Is this a function? No, this is not a function. Why? Because the number 3 was not assigned to any value in the range. That makes this example not a function. What about this? Is this a function? This is fine. So take note, if I'm going to relate this to students, each student gets only 1 grade. More than 1 can get an A, and I don't have to give any D's. So meaning, pwede si student 2 and student 3 can get an A, and no one can get a D. Okay? That's totally fine. That is still a function. Okay, let's have a function notation now. We commonly call functions by letters because function which starts with the letter F, it is commonly used to refer to functions. Mo ng f of x. So, the left-hand side of this equation is the function notation. This one. It tells us 2 things. We called the function f, and the variable of the function is x. So take note, f there. This means the right-hand side is a function called f. And this means the letter x there means that the right-hand side has the variable x in it. Or take note, variable x, variable f, x. If I'm going to have f of c, therefore, x here becomes letter c. Depende man sa gamito na itong letters sa atong expression. Now, the left side does not mean f times x. You read this a function of x or f of x. Okay? You don't read that as f times x again, class. You read that as a function of x or f of x. Now let's consider this. Remember this tells you what is on the right hand side. It is not something you work. It says that the right hand side is the function and it has x in it. So we have a function called f and has the variable x in it. Using function notation, we could then ask the following. Find f of 2. This means to find the function f, and instead of having an x in it, we put 2. So instead of having an x, we put the number 2 here, and we will be finding the value of the function when x is equal to 2. So the value of x here is simply equal to 2. So what are we going to do there? We substitute 2 over here. So that becomes f of 2. The x's there becomes 2. And take note, don't forget order of operations. Start with the powers or simply the exponents, then multiplication, then finally addition and subtraction. Let's start with the exponents. So you have here 2 squared, that becomes 4. Then you multiply 2 and 4 to get 8, multiply 3 and 2 to get 6, then you write 6. 8 minus 6 plus 6, you will get 8 there. Therefore, the function f of 2 is equal to 8 for this function. Okay? Let's have f of negative 2. And I'm going to be having this function. So I will be, this means to find the function f, and instead of having x, you substitute. So that becomes that one. And of course, please do not forget operations. Exponents first, followed by multiplication, and finally, last is addition and subtraction. So I'm going to have the exponent. Negative 2 squared, this one, that is 4. So I'm going to multiply 2 and 4 to get 8. Multiply negative 3 and negative 2 to make that positive 6. Apply the rules of integers when multiplying, of course. And you rewrite positive 6. So you're adding the 3 numbers there, you're going to get 20. There you go. Now, I'll be talking about 4 function operations, the basic operations, of course. Let's start with addition. F of g, f plus g, that's simply f of x plus g of x. Multiplication, subtraction, and division. Now, to further explain the 4 operations here of functions, let's have an example. Let's have adding and subtracting functions. Let's compute f of g and also f plus g and f minus g. For f plus g, we have this. I'm going to be adding 3x and 2x minus 12. I'm going to add 3x plus 8 and 2x minus 12. That's so easy. And then you combine like terms. So that is 5. Positive 8 minus 12 is negative 4. So therefore, this is now the value of the sum, the sum of the 2 functions. While for the difference of the 2 functions, you will be subtracting 3x plus 8. There you go. Please do not forget to put parentheses there. The parenthesis is very, very important. Minus 12. Why? Because we will be distributing that. So that becomes, so ang solution ani, 3x plus 8 minus 2x plus 12. Take note, negative times negative is positive. So 3x minus 2 is x. Positive 8 and positive 12 is positive 20. And this is now the difference of the 2 functions. Okay, let's have multiplying functions. You still remember FOIL method? There you go. Diba? We will multiply the first term. So multiply this and this function. The result is x cubed. Multiply the outer terms. Multiply the inner terms. And multiply the last terms. Now, take note, there are no similar, so you cannot combine any of the terms there. What if I'm going to give you x plus 2, 3x plus 2, multiply that to 2x minus 5. For example, distribute. This is 6x squared. Distribute the outer terms, negative 15x. Multiply the inner terms, plus 4x. Multiply the last terms, that's negative 10. You have noticed now that there are common or similar terms. So bring down 6x squared. What is negative 15 plus 4x? So take note that will give you negative 11x. You will subtract that because they have unlike signs. Minus 10. And there you go. That is the answer when you do FOIL method between 3x plus 2 and 2x minus 5. There you go. Then now let's have dividing functions. It's so simple. If you want to divide f of x, like x squared minus 1 all over x plus 1, if your numerator or denominator are factorable, you need to factor it out. For example, this is factorable. So I factored it as x minus 1 and x plus 1. Remember difference of two squares? So this is how you factor it. Then you will be canceling the 2. You are left with this. Now what if, sir? What if, sir, I have 3x minus 5 over x minus 3? Is it factorable? No, it's not factorable. Therefore, this is already final. And there you go. Those are the 4 operations.